module. You will learn about the addition of vectors by the analytical method. Earlier, you learnt about the addition of vectors by the graphical method. The accuracy of the results obtained using the graphical method depends on the scale you chose and your ability to draw exact parallel lines. You can get accurate results using the analytical method of vector algebra. Before learning the analytical method of vector algebra, you should understand the concept of resolution of a given vector in any two required directions. To understand the resolution of vectors, consider three vectors A, B, and C lying in one plane. In this case, you need to resolve vector A along the directions of B and C. O and P are the tail and head of A respectively. From O, draw a line parallel to B, and from P, draw a line parallel to C. Let these two parallel lines intersect at Q. On the line OQ, display an arrowhead at Q. Similarly, on the line QP, display an arrowhead at P. In this case, the length of the line OQ is 2.5 times the length of B, and the length of the line QP is 3.2 times C. Hence, from the triangle OPQ, you can write A is equal to 2.5 times B plus 3.2 times C. 2.5B and 3.2C are known as the components or resolved parts of A along the directions of B and C. In this expression, B and C are the unit vectors, and 2.5 and 3.2 are real numbers. Usually, vectors are resolved along the axis of a rectangular coordinate system using unit vectors for convenience. Unit vectors have a magnitude equal to unity, and they indicate a particular direction. You do not specify any dimension or unit for these vectors. They only indicate direction. Unit vectors along the direction of the x, y, and z axis of the rectangular coordinate system are denoted by I cap, j cap, and k cap respectively. These three unit vectors are perpendicular to each other, as the three rectangular coordinate axes are perpendicular to each other. Now, let's see how vectors are added by the analytical method. First, we will discuss vector addition for planar motion or two-dimensional motion. When dealing with planar motion or two-dimensional motion, you need to resolve the given vector along I and j only. Now, consider a vector A on the xy plane. From the head of the vector, draw perpendicular lines to the coordinate axis to obtain vectors A1 and A2. Hence, we can write A is equal to A1 plus A2. Let this be equation 1. As A1 is parallel to I, you can write A1 is equal to AXI. Let this be equation 2. Similarly, A2 is equal to AYJ. Let this be equation 3. Substituting 2 and 3 in 1, you get A is equal to AXI plus AYJ. AX and AY are the magnitudes of the components of A in the x and y direction. Here, A makes an angle theta with the x-axis. You can write AX is equal to A cos theta and AY is equal to A sin theta. Let these expressions be equations 4 and 5 respectively. AX and AY can be positive, negative or 0 depending on the angle theta. A can be specified by its magnitude and theta, or its two components AX and AY. When A and theta are given, AX and AY can be determined using equations 4 and 5. When AX and AY are given, you can find A and theta as shown here. Now, let us solve a simple problem to understand the procedure associated with this method. Two vectors A is equal to 7i plus 3j and B is equal to 5i plus 8j are given. You are asked to add these two vectors and find the resultant vector C. To understand the procedure clearly, you need to first solve the problem using graph paper. To draw vector A, first mark the point 7, 3 on the graph paper. 7 is a coefficient of I and 3 is the coefficient of j. Join this point with O with a straight line. Draw an arrowhead at the end of this line. This line with the arrowhead represents vector A. Similarly, represent vector B by joining the origin O to point 5, 8. Complete the parallelogram by drawing parallel lines from the arrowheads. Draw the diagonal passing through O. Display an arrowhead at the end of this diagonal. This diagonal represents the required resultant vector C. Check the coordinates of the arrowhead point of C, which should be 12, 11. You can also solve this problem without graph paper. You need to simply add the coefficients of I and j as shown here. However, representing the given vectors on graph paper helps you visualize the procedure. Now, let's discuss vectors in three-dimensional space. Create x, y, and z coordinate axis passing through point O. Then represent a vector A passing through O. Here, alpha is the angle between vector A and the x-axis. Beta is the angle between vector A and the y-axis. And gamma is the angle between vector A and the z-axis. In this case, its three components along x, y, and z direction can be written as AX is equal to A cos alpha, AY is equal to A cos beta, and AZ is equal to A cos gamma. Here, A is equal to AX plus AY plus AZ, which can be written as AXI plus AYJ plus AZK. Here, AX, AY, and AZ are scalars, and I, J, and K are unit vectors. The magnitude of A can be written as the square root of AX square plus AY square plus AZ square. Let us solve a simple problem using isometric graph paper. two vectors A is equal to 6i plus 4j plus 9k and B is equal to 4i plus 3j plus 2k are to be added to find vector R. To visualize the process, you can represent A on the graph paper by joining the point 6, 4, 9 to the origin O. Similarly, join 4, 3, 2 to the origin O to obtain B. You can draw the resultant vector R after determining the coefficients of I, j and k by simply adding the corresponding coefficients of A and B. Thus, you have learned the analytical method of vector addition for two-dimensional motion and in three-dimensional space. You have now reached the end of this module. In this module, you learned that unit vectors have a magnitude equal to unity and they indicate a particular direction. When dealing with planar motion or two-dimensional motion, you need to resolve the given vector along two directions, say I and j only. To add vectors, you need to simply add the coefficients of I and j as shown here.